Welcome to another One with Math video. In today's video, given x equals 4 tangent theta, rewrite the square root of 16 plus x squared in terms of theta, where theta is in the first quadrant. So our focus here is to rewrite the square root of 16 plus x squared. We notice that we need an x squared and we're given x equals 4 tangent theta. So for method 1, we'll square both sides. And so we have x squared equals 16 tangent squared theta. And now let's substitute into the square root of 16 plus x squared. We'll substitute in. This is what we get. We'll notice there's a 16 plus 16 tangent squared theta. They both have a 16 common, so let's factor it out. And we have the square root of 16 times the quantity, 1 plus tangent squared theta. Now, from the Pythagorean identity, we have that 1 tangent squared theta is equal to secant squared theta. So we'll substitute that in, and we get the square root of 16 times secant squared theta. Now we're going to take the square root. So square root of 16 is just 4, whereas the square root of secant squared theta is the absolute value of secant of theta. Now, since we're also given that theta is in quadrant 1, this means that all 6 trig are positive. So we have secant of theta is always positive. Now, since secant of theta is positive, there's no point in having absolute value. So the absolute value of secant of theta is equal to secant of theta. So substitute in, we get 4 secant of theta. So the square root of 16 plus x squared is equal to 4 secant of theta. This is the algebraic approach. Now let's look at a second method, which is going to be more towards a geometric approach. So method 2, take a look at the x equals 4 tangent of theta. We'll divide both sides by 4, and so we have tangent of theta is equal to x over 4. Recall that the definition of tangent theta is opposite over adjacent. So we'll draw a right triangle. And the reason why we draw a right triangle is because we know it's the angle is in the first quadrant. So it's an acute angle. So we have the opposite side to be x, the adjacent side to be 4. By the Pythagorean theorem, we have 4 squared plus x squared is equal to the hypotenuse squared. Let's just solve c squared. And then we'll square both sides. So we get the hypotenuse to be the square root of 16 plus x squared. Since we're looking for the square root of 16 plus x squared, we will need to use the hypotenuse. And then let's pick a different side. We can use the opposite side, which is called x, and we can use the adjacent side, which involves 4. Since we don't really want the x, let's use the 4. So hypotenuse and adjacent. What relates these two are two things. One, you can use cosine, which is adjacent over hypotenuse, or we can use secant, and that's the one we're going to use. Recall that secant theta is equal to hypotenuse over the adjacent. So secant theta is equal to square root of 16 plus x squared over 4. Multiply both sides by 4, and we get 4 secant theta is equal to square root of 16 plus x squared. And that's what we're trying to find. So here's the algebraic approach, method 1, and here's the geometric approach, method 2. Comment, like, and subscribe. Thank you.